Find the solution of the given initial value problem. So we have an ordinary differential equation, second order, and two initial conditions. So let's find the fundamental set of solutions. So here we first find the characteristic equation. Characteristic equation is r squared plus 8r minus 9 equals 0. Let's solve this by factoring because it factors. Plus 9r minus 1. Okay, so r equals negative 9 and 1. That means e raised to negative 9t is one solution and e raised to 1t is another solution. So these are two solutions and their linear combination is a general solution. But if you look at closely where we evaluate y, the solution y and y prime, they are at 1, not at 0. So this one, then we can write another pair of solutions like this. Okay, these are solutions e raised to negative 9 t minus 1, e raised to just t minus 1. These are also solutions. How? All I did here was I multiplied this by e raised to negative 9. Okay, or 9, just 9, positive 9, e raised to 9, which is a number. When I multiply these two, then I get e, and negative 9t plus 9 is same like this, and do the same thing here. Okay, in the second, okay, I multiplied first by e to the 9, I multiplied second by e to the negative 1, and when I combine I get e t minus 1. Okay, and by the way, here is 1, so the way we wrote 9t, that would work the best when we had 0 here. Okay, with this 1, when we plug in 1 here, 1 minus 1 0, here 1 minus 1 0. That's why I'm writing t as t minus 1, this t is t minus 1. Okay, and this is valid because we are just basically multiplying these solutions by numbers, and by the principle of superposition, when we multiply a solution by a number, that's still a solution. Okay, and the way we wrote in this way, writing t as t minus 1, t as t minus 1, our calculations will be a lot easier later. Okay, these are also solutions, and we can write a general solution now, which is y is a function of t equals c1, or I can write a times first solution plus c2 or b times second solution. Okay, eventually we find the values of a and b using the initial conditions, and we come back here and write down the final solution. To make use of second initial condition, it has derivative prime, so we need to find the derivative of this y. Find the derivative, that's negative 9a e to the negative 9t minus 1 plus just itself b e to the t minus 1. Okay, say 1, 2. So use the first or second, doesn't matter which one you use first, but look at the second is 0, so let me use the second initial condition. Okay, using y prime 1 equals 0, so y prime is here, using y prime at 1 equals 0, that we have to use in 2, we get, so y prime is 0 when t is 1, so this y prime is 0 when t is 1, so plug in 1 here, so negative 9a e raised to, now 1 minus 1 0, so e raised to 0, which is 1, So here e raised to 0, which is 1, so that's plus b. So 0 equals negative 9a plus b. We can isolate b in fact here. We'll get a system of two linear equations, and we can solve by the method of substitution or elimination. So this is same as, or I can isolate b equals 9a. Now let's use the first initial condition, which is y at 1 equals 1. Using y at 1 equals 1, that's obviously in star here. So y value is, we get y value is 1 when t equals 1. So I am using here y is 1, so a e raised to 0 is 1, so this is a plus b. Okay, now I can use b equals 9a from previous line and find the value of a, or 1 equals a plus b is 9a, so a plus 9a 10a, so we get a equals 1 over 10. Now if we plug this back here, we get b. Okay, then b equals just 9 times a, 9 times 1 over 10, so 9 over 10. So we have a and b, so we go back to the star here and write down the final answer. Okay, so thus yt equals a, that's we found 1 over 10, e raised to negative 9t minus 1 plus b, which is 9 over 10 e raised to t minus 1. Okay, final.